Hey all! Today's video is about unit roots and the Dickey-Fuller test to detect a unit root in a time series. The source reading on this section is very sparse, so I would say this material is low priority if you have other topics to review. Let's dive in. A unit root is a characteristic in time series analysis that indicates a series is non-stationary. Non-stationarity means that the statistical properties of the series, such as its mean and variance, change over time. In a series with a unit root, shocks or changes have a permanent effect on the level of the series. This is in contrast to a stationary series, which tends to revert to its mean. Let's look at the following time series model to determine the presence of a unit root. In this model, mu0 is the constant term, mu1 is the coefficient for the time trend, phi is the autoregressive parameter relating the previous value to the current value, and epsilon is the white noise error term. Let's look at three cases of this model to determine the presence of a unit root. The first case is when phi equals 1. In this case, the model simplifies to the random walk model. Each value is the previous value plus a random error and a drift term. A random walk contains a unit root and is non-stationary. The second case is when phi is less than 1 and mu1 is 0. We assume no time trend. The model becomes a first-order autoregressive model. In this scenario, the series tends to revert to its mean. This indicates stationarity, meaning the statistical properties do not depend on the time at which the series is observed. The last case is when phi equals 0. This simplifies to a linear trend in time model. The value of y increases or decreases linearly with time, with a random variation added by the error term. We covered the properties of a random walk, an AR1 model, and a linear trend in time model in previous videos, so these scenarios and their properties should be familiar if you've already watched those videos. The Dickey-Fuller test is a modified t-test to assess whether a time series is non-stationary due to a unit root. Suppose we are running a regression on the model from earlier. The issue here is that if the variable yt is a random walk, we encounter non-stationarity, which can invalidate standard regression results. Instead, we can take the difference of the series, which is done by subtracting the model from the previous time period, t-1, from the model at the current time period, and use least squares on the differenced model instead. Note that we group some terms and define them as beta 0 and beta 1 to simplify the equation for regression analysis. The Dickey-Fuller test is a modified t-test. We then test the null hypothesis that phi is equal to 1. This implies a unit root exists since the series is non-stationary. We test this against the alternative hypothesis that phi is less than 1, indicating the series is stationary. Under the null hypothesis, the t-statistic follows a special distribution tabulated by Dickey and Fuller. One criticism of the standard test is that it assumes the error terms are not autocorrelated. To address this, we use the Augmented Dickey-Fuller Test. This version includes additional lagged difference terms, where p is the number of lags. These terms help capture and account for any autocorrelation in the error terms. There is no consensus on the selection of p. Thanks for watching. For a comprehensive written course, hundreds of practice problems, progress tracking, and AI-assisted tools, visit the Actuarial Nexus. See you in the next lesson.